Welcome back to our live training session. In this training module, we're going to be taking a look at dialing in our full throttle once again, but we're going to be engaging VTEC and learning how to calibrate our fuel spark and variable cam control relative to our VTEC being engaged. We'll find that things change when VTEC is on. It's going to give us a completely different cam profile for the engine to operate on. So we'll find fueling should definitely have to increase from our main fuel table because we're making more power and torque. We're going to need more fuel. So that's right off the bat. Definitely going to need to go in and touch up our fuel table. Second thing is variable cam timing changes quite a bit going from low to high cam. We generally can run a little bit more cam advance compared from low cam to high cam. We also generally can run about 2 to 4 degrees more spark timing safely on our engine on high cam compared to low cam. Now, when we dialed everything in that last training module, we've optimized our fuel delivery for low cam. We've optimized our spark timing for low cam, full throttle, and our variable cam target here was completed and compiled based on how the engine was responding on low cam. Now on high cam, things are going to change. What we're going to do here is actually lock our VTEC on at 3,000 RPM. That's the lowest you can safely lock and engage VTEC because you need at least 50 pounds of oil pressure at the cylinder head for VTEC to positively engage. Now, I'll lock VTEC at 3,000. We're going to start our pulls maybe about 34 or 3,500 on the main line. We're going to go all the way out to about 8,400. When we're going and doing our pulls, initially we want to baseline everything with the variable cam timing zeroed out. So we have to go and actually make some changes to our variable cam target table. So this table was built around low cam. Unfortunately, we don't have two tables like the factory ECU where we have a low and high cam variable cam target table. We have to make everything work on one table. Same with spark timing, same with our fuel. So everything has to fit and work on one singular table. So let's look at a few things here. First thing, let's go and engage VTEC. If we go here to the other functions option, we find variable camshaft VTEC. We're going to say turn on over, and we're going to set this to 3,000 RPM. We're not going to use the turn on under option. So anytime we're above 3,000, we're engage VTEC. Anytime we're below 3,000, it's going to turn off VTEC. Now this is actually really not ideal for VTEC tuning because we actually want to have a hysteresis where if we are at 3,000 RPM or at 29,999 RPM, so roughly RPM less than 3,000, and we're hovering right between the two, it's going to gauge VTEC. It's going to cycle on and off and on and off and on and off. And that can create some problems for us. So ideally, we'd like to have a hysteresis where if we're engaging it at 3,000, we have to wait till at least 2,800 to disengage. That way it gives us a little bit of a kind of a dead band so the VTEC can't essentially turn on and off. The other thing we'd like to have control over would be map pressure and throttle position. So we want to engage VTEC low, or as low it's going to make sense for us, but we don't want to engage it in part throttle cruising. That's not ideal. We'd like to have throttle position and map pressure, manifold pressure as variables to allow us to turn on VTEC. So meaning we have to meet a certain RPM threshold, we have to meet a certain throttle position and a certain map pressure for VTEC to engage. Fuel Tech does not have any of that present in this specific firmware that we're running here, 5.21, does not have it available. It's really a poor way to control VTEC. Yes, it works, but it is not ideal for a road race or a street going vehicle. If you're drag race, it doesn't necessarily really matter, but again, I'd still like those variables for programming. So we're gonna lock our VTEC on at 3,000, and we need to go touch up our variable cam target table. I'm gonna say here above 3,000, 3,500 and above, I'm going to set at my full throttle here, all of my cam target to 0 degrees. Now I'm not going to go in below 3,000 and change my cam target because what worked on low cam will still be locked in low cam there, will still be relevant. That allows me to not have to go back in and touch up my fuel table essentially below 3,000. So I can keep everything I have going on here that we've calibrated in the last video in place. We'll deal with everything above this point in the last few rows of the table to dial in our fuel table. So we want to baseline everything on our 0 degree, just as we did in the low cam tuning. Then we'll walk our cam timing up from 0, 10, 20, 30, maybe even 40, possibly 50. I have a 50 degree VTC gear on the engine installed on the cam, so I do have the ability to go up that high. We'll have to see how the engine responds. Once we map everything out and we know what works based on walking up from various different cam targets, we'll then be able to build our cam composite blend. Then we can touch up our fuel table. Then we can go in and tweak our spark timing a little bit and finally settle on a proper VTEC engagement point. So this process is fairly straightforward, but we want to pay attention to details as we're tuning. Now, what we're going to be doing here is baselining at 0, going into the main fuel table, touching up our main fuel table values at 0 degree, then walking the cam timing up, then watching the O2 correction each time we're adjusting our variable cam timing and seeing the power differences based on what the O2 correction is showing us. We'll back up what we see based on the log data, looking at the main line with each pull and see if we're gaining power to back up what we're finding from the data, seeing from the log. And if you don't have a chassis dyno, that's going to be where you're at. You're only going to take a look at the log data. And to get an evaluation as to what the engine's doing and how it's responding, you'll have to watch what your fueling is doing. If we're seeing positive gains, the O2 correction is going to add a lot more fuel. And if we're losing power as we're adjusting the variable cam timing, we'll find it's going to take away fuel. We can get a feel for what's going on with the engine pretty quickly as long as we're paying attention to the details I outlined in the training module. So we'll dial everything in. We'll do our cam composite blend. We'll touch up our fuel table then. And finally, maybe adjust our spark timing a little bit, maybe 2-3 degrees at most. And that'll be it. All right, so we have everything in order here going down. We've adjusted our cam target. 0 is where we're going to begin here. I am going to save this now as a new file name, and I'll call this High Cam Tuning, VTEC Tuning. And I'm going to go here and write to the ECU and write this to the computer. Now, we need to go into the mainline and set up the mainline dyno so it'll allow us to do our full throttle pulls. It's pretty easy. Let's jump into the mainline screen here. We can see the main screen. This is going to be where we do the normal part throttle type of control as we're driving and trying to calibrate things. We actually want to be in our dyno mode. Let me flip over to the dyno mode, clicking F2. We're going to go here to setup, and this is going to allow us to have our start and our end speed. Start speed is going to be where we want to start or run at. End speed is where we're going to complete or end or run at. We're going to go between these 2 points. We also have a ramp rate that controls the duration, which in turn controls the engine load. We want to be specific with this for the duration and where we want to start and end our run at. So the start speed here, we can see down here, this is going to translate the hub start speed to engine speed. I want to go here and be locked into VTEC when I'm doing the pull, so I'm going to say at least 3200 is fine. It actually initiates the run a little bit before that, so we'll be locked into VTEC to begin our pull. Now, we want to end our run right around 8500 max. We have the rev limiter set at 89,000, so we won't hit the limiter. I don't want to rev the engine much past 85. That should be fine with the stock cams in here. It's going to be about the limit of where the engine responds. If I go in here and I start to select various different hub speeds, we're going to find right here, 1550 hub speed gives me an 8400 RPM peak point where I want to stop my run at. So I have my start and my end point in RPM. Then I'm going to go ahead and take a look at my duration. This is how long we're going to make the run for. We like to see this around 6 to 7 second mark. It's 7.5 seconds now. I'm going to go up here to the ramp rate and actually go up to a higher ramp rate, and that lowers the duration or the load on the engine. I want it pretty similar to what I put the load for low cam on the engine for high cam. We were at about a 6.7 or 6.8 duration on the low cam. We're at 6.6, so that should be fine. Let's click OK. Let's click begin, and now the dyno is ready to go to do our tuning process. So we've uploaded the change for the variable cam target. We have VTEC locked in at 3000. We'll fire it up. We're going to wait until the wideband comes online, and then we'll do our pull, and we'll see what's going to happen here. Again, touch up the fuel table around 0 degree, walk up the cam timing, figure out the cam blend, touch up the fuel table again, then touch up the spark timing, and finally the VTEC engagement point. That is the order of operations that we're going to move in here. Let's go ahead and try to fire it off here. So I'm out of gear. You see fuel pressure is 0 right now, but it should be okay when we're cranking it, so let's try to fire it. There we go, it finally fires off. Now, a lot of that odd cranking problem, as I've been describing through the last few training modules, it's likely due to not the cranking fuel, not the spark, or the airflow for cranking. It's likely due to the main relay power supply to the engine harness. The crank sensor gets its power supply from the main relay, and as I'm cranking, you'll notice the RPM drops to 0 a few times. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.